All right, in this video, we're going to look at the interior angle sums of a polygon. Now, when we want to look at the interior angle sum of a polygon, every polygon has interior angles and exterior angles, and we'll talk about exterior angles in a different video. So we're going to talk about interior. And what does interior mean? That means inside. And what is sum? That means total. And so we're talking about the total of all the angles inside a particular polygon, okay? So we're going to look at these interior angle sums starting with the first one. What is the smallest polygon we can have? Triangle, good job. You win no money for that. So the number of sides is 3. What's the name of that particular polygon? That's a triangle. A triangle has 3 sides. Okay, so what we're going to do now is we're going to look at drawing these figures. So keep that in mind. Triangle has 3 sides. All right. If I draw a triangle, how many diagonals? Now a diagonal, remember a diagonal is a segment that connects or whose endpoints are, remember a segment has 2 endpoints, whose segments are 2 vertices, 2 vertexes, for those of you that don't like to make things plural. So I want to pick a vertex. I can pick any vertex. Pick a vertex, pick a card, any card. Pick a vertex. I'm going to pick a vertex. I'm going to pick this one because I want to. Are there any diagonals in this figure that I can draw? Well, if I connect this vertex to this vertex, isn't that already there? That's already a side. Same thing here. There are no diagonals here. Okay? There are no diagonals here. So, but what do we already know the interior angle sum is for a triangle? We already know a triangle is 180. When I add all 3 of these angles, these guys together, I get 180, right? Okay, let's go back to our chart. So I've got the interior angle sum of a triangle. We couldn't draw any diagonals. How many triangles are inside of a triangle? Yes, this is a duh question. 1 triangle per triangle. What's the sum of the interior angles of a triangle? 180 degrees. So what's the sum of this particular polygon? Well, it's a triangle, so if it's a triangle, the sum is 180. Okay. So that's the interior angle sum of a triangle. So let's go to the next one. Let's look at the 4-sided figure. What do we call a 4-sided figure? This is the one nobody can spell. This is not a square. We're more general. This is quadrilateral. That is a quadrilateral. That is a 4-sided figure, okay? So let's go back to our pretty pictures, and I'm going to draw a quadrilateral. It doesn't have to be a square or a rectangle. A quadrilateral is any 4-sided figure. I'm going to pick a vertex, and I'm going to try to draw a diagonal. I'm going to pick this vertex just because I want to. I can draw how many diagonals? 1. I can't draw any more though, can I? Everything else I try to do to connect a vertex is a side already. So how many triangles are created here? 2 triangles are created, right? So I've got 2 triangles. And what's the sum of each triangle? What is the sum of the interior angles of each triangle? Well, each one is 180 degrees, right? Do you see how I can create 2? Okay, so let's go back to our chart. How many diagonals was I able to draw? 1. How many triangles did that create? 2. How many degrees are in each triangle? 180. So therefore, what was the total interior angle sum of the quadrilateral? 360. What did I do? I multiplied, right? I drew a quadrilateral. It had 4 sides. 1 diagonal could be drawn, which created 2 triangles at 180 degrees a pop. So that's 360. So let's move on. Now let's do a 5-sided figure. That is a pentagon. Pent means 5. Okay? So pentagon is 5. So let's go over to our handy-dandy picture here. I'm going to draw a pentagon now. 5 sides. Whoops. Ignore that. That's a pentagon. Ignore that. That's my little artwork. So I'm going to pick this vertex. How many diagonals can I draw in a pentagon? 2. So I've got 2 diagonals. How many triangles? Triangles. How many triangles does that create? 3 triangles at how much? 180 degrees a pop. So now when I do my pentagon's got 2 diagonals, which creates 3 triangles at 180 degrees a pop. So that's 540 degrees. You see where we're going with this, okay? So let's look at the next one. The next one is a hexagon. That's a 6-sided figure, okay? A hexagon is 6 sides. So let's look at the hexagon. If I draw a hexagon, it's got 6 sides. I'll actually count properly this time. 4, 5, 6. If I have a hexagon, I'm going to pick this vertex because I want to. I can draw 1, 2, 3 diagonals, right? I'm going to pick a vertex, draw a diagonal. That creates how many triangles? 4. So there are 4 triangles inside this at 180 degrees each, right? So if there's 4 triangles at 180 degrees each, I was able to draw 3 diagonals, which created 4 triangles at 180 degrees apiece. So that leaves me with 720 degrees as my interior angle sum. Now you see the pattern here. Let's keep moving. The 7-sided, that is a heptagon. You can also call it a septagon. That has 7 sides. Well, look at the pattern. How many diagonals would it have? 3 sides, no diagonals. 4, 1, 5, 2, 6, 3. So this will have 4. How many triangles? Well, if it has 3 sides, it has 1 triangle. 4 sides, 2. 5 sides, 3. 6 sides, 4. So this is going to have 5 triangles. At what? 180 degrees a pop. So that's 900 degrees. Let's move on to octagon. So now we've got an 8-sided figure, which is an octagon. Okay, so that octagon has 5 diagonals, 6 triangles at 180 degrees a pop. So that's got 1,080 degrees interior angle sum. Then we go to 9 sides. A 9-sided figure is called a nonagon. Not ninagon, nonagon. It has 9 sides, and it can make 6 diagonals, which means 7 triangles at 180 degrees a pop, which is going to be 1,260 degrees. Then we have the 10-sided figure. That is the decagon. The decagon has 10 sides, which means 7 diagonals, 8 triangles, 180 degrees, which is 1,440 degrees. And I'm trying to rush before the bell rings here, so we'll go to the next 2. An 11-sided is called an undecagon or a hendecagon. That has 8 diagonals, 9 triangles at 180 degrees apiece. So that one is going to be 1,620 degrees. And then we have the dodecagon. The dodecagon has 12 sides, 9 diagonals, 10 triangles at 180 degrees, so that's 1,800. So look at your pattern here. Look at the pattern. What if I just had an n-gon? I didn't know how many sides. N sides. How many diagonals will an n-gon have? Well, we'll look at the pattern. 10 sides is 7 diagonals, 11 is 8, 12 is 9. This is n minus 3. Whatever the number of sides is, minus 3 is how many diagonals you have. What about the number of triangles in this column? 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. So what you notice is 12 sides, 10 triangles. The number of triangles is n minus 2. It's 2 less than the number of sides. It's 180 degrees a pop for each triangle, which means if you want to find the interior angle sum of a polygon, you multiply n minus 2 times 180. n minus 2 times 180 is your formula, because n minus the n is the number of sides. The n minus 2, the whole thing, is the number of triangles you can create, and the 180 is the sum of the interior angles of a triangle. So you take the number of sides, you subtract 2, and that tells you how many triangles you can divide the figure into. And what do we know about a triangle? There's 180 degrees per triangle, right? So I want to take the number of triangles and multiply it by 180. If I have a triangle, that's just 180. If I have a quadrilateral, I was able to divide it into 2 triangles at 180 apiece. That's 360. A pentagon has 5 sides. I can divide it into 3 triangles. So 3 times 180. Look at all this. This is 3 minus 2. 4 minus 2. 5 minus 2. 6 minus 2. 7 minus 2. 8 minus 2, 9 minus 2, 10 minus 2, 11 minus 2, 12 minus 2, and n minus 2. So that's where we get the formula for the interior angle sum of a polygon.